All right, I got things I can certainly talk about, but I'm happy to have you drive the conversation if you got any questions or comments. How about that shift lock, huh? Caps lock? Yeah? No? All right, yeah.
Can we talk about strings for a little bit?
Yeah, let's talk about strings. Anything specific, or you just want me to kind of paint a picture?
Paint a picture.
All right. Oops. So, we have our basic types, int, char, float. I don't know if we've talked about it. There's one called double. Let's see, what other basic types do we have? There's actually a long integer. There's a long integer. You're going to see those. Definitely, I don't think I've ever seen this in the wild before. I've seen this a couple times. An integer is any whole number, positive or negative. A character is normally specified with single quotes and a single character in those single quotes. A float is got some sort of fractional portion there. A double is just like a float, except that it has a larger capacity, whereas this might be 8 bytes, this might be 16 bytes. So it just lets you store increasingly large numbers in it. And then that's what these are. These are variants on integers. They literally just allocate more and more space for the single variable so that you can have very large numbers in them. So those are all built into the language. And then there are a number of things that aren't built into the language but are standard with the language, which means that the primitives of the language are used to build these standard things, such as cout. So any C++ compiler you come across has something called cout. When you send something to cout, you're sending it to the screen. It's not built in to the DNA of the language. However, it is standard with the language. And what's another way of phrasing it? Cout is something that a programmer wrote, right? Int, long, float. These are things that people who create languages, compiler writers, those people who created G++, created these built-in types. But something like cout, I could have written in principle, meaning I could take the raw built-in stuff of the language and have created cout. Cin is the same way. And then there are types that are not built into the language but are standard with the language, and one of those is string. And a giveaway here in my programmer's editor is you'll notice that neither cout nor string have that color coding of green, and I think it would have been fine if they'd been made green since they're part of the standard library, but whoever decided to make built-in things in the language green knew that cout and string aren't built into the language. They're just part of the standard library, so they didn't bother highlighting those green. The reason for string is, so C++ is a language that is built on top of C, and the C language has no concept of a string. We haven't talked about arrays yet, but I'll give you 10 seconds of arrays and then move on. If I need 5 integers, I could say int A, int B, int C, int D, or I could of course call them whatever I want. But there comes a point in time where if they're all representing the same thing, it becomes a bit of a hassle. For instance, if I wanted to keep track of the age of everyone in this class, I could say this is the age of student 1, this is the age of student 2, this is the age of student 3. But it becomes burdensome to do that. We've got, in this case, a room of about 60 students. For me to keep track of 60 different variables, which for intents and purposes are keeping track of the same thing, I want a different mechanism, and the language provides that. It'd be similar in mathematics to a vector. And I can just say age, and I can say how many of them I want. And then I can do things like age sub 13 is equal to 22, right? Or excuse me, without the int. So that's how I would access any one of those 60 ages, is just by providing which one I'm interested in the square braces here. And this doesn't have to be a hard-coded number. For instance, I can say int x equals 13, and then I could say age x is equal to 22. Right? Now it becomes quite useful as you develop programming algorithms to be able to deal with arrays that way. Anyway, that's a long way of saying that the C language did not have strings, they had arrays of characters. So if I wanted to store my name, Todd, I would need to have an array of 4 characters, T-O-D-D, and actually you needed a 5th character to represent the stop point of the string. And they are burdensome to work with. Now, if you're fluent at programming, you can of course work with them, but they are very quirky, they're difficult, they're not very easy. So comes along C++ and they decided, you know, we need a type that represents string to make them easy to work with. And that is exactly what this is. This is a type that some programmer wrote that became part of the standard that makes it very easy to work with strings. And then a string is just simply anything in double quotes. It could be nothing in double quotes or a single character in double quotes. Note the distinction between line 14 and line 8, that the character type demands single quotes and the string type demands double quotes. And there always has to be a single character sitting in here, whereas strings can be empty, or they can have you know, a whole textbook worth of text between the double quotes. So that's a string type. They've made it very convenient to use. For instance, you can do things like, let me actually write a little bit of code. I will leave this. Let me rename this. Move strings.cpp. I'll call that types.cpp. Actually, I should have copied it. Let me copy it back. Types, strings. So now I've got 2 files that have exactly the same contents, but I'm going to come into strings now and I'm going to delete that other content. All right. So let me make this a little more useful. I can spit out that string, and I'll come over here and I'll say G++, standard equals C++11, and this is called strings.cpp. There it is, a.out. I'll run it. Okay, no surprises. What's nice about this string type is that it's easy to manipulate them. For instance, I can say my string equals my string plus space Gibson. And now I can, what I'll do is I'll come up to line 8, YY to copy the line, P to put. I'll print it out again. I'll come over here. I'll compile. I'll run it. And so very intuitive to use these strings. You can actually use them as if it was an array of characters. So for instance, if I wanted to print out so this would be the first, second, third, fourth, fifth, sixth. If I wanted to print out the sixth character, I'll again copy this line, YY to copy the line, P for put, WWW, whoops, HH to go back. So the reason 5 is the sixth character is that counting begins at 0. Invariably in the language, everything begins at 0. So if I was to put a 0 there, that would be the T in Todd. All right, we can check that out. And sure enough, there it is. So that's how you use strings. That kind of answer your question for you?
Yes.
Okay. Yes?
Is there a way to remove a whole directory?
Yes. You mean particularly if it has contents?
Yeah.
So I can create a directory, mousey, and of course well, some of the times it's straightforward to remove it. There it is, gone. However, the issue comes if I have the directory. Let me clear the screen, ls. All right, there's mousey. I'm going to move a.out into mousey. And now if I try to remove the directory mousey, it'll complain that the directory is not empty and it won't obey your wishes. So there are a couple options. I could cd down into mousey, and then I could remove the contents. I could remove a.out. But if mousey contains other directories and other files, for instance, inside, again, I'm in mousey right here. If I create another directory, caddy, then I would have to remove a.out and remove directory caddy, and it goes on and on, right? If let's say I wanted to remove this directory, just to show what a pain it would be. Where am I? Okay, I'm in that directory. So there's a whole bunch of stuff there, and it would take me quite a bit of time to remove all that stuff individually. So there is a shortcut. Let me get out of, all right. I can say RM, and there's a -R option, and the R, that stands for recursive, meaning it'll go down into mousey. It'll remove everything in there. If there are directories in there, it'll go into those directories and remove everything in there. So it'll basically remove everything from mousey on down. And just the mild warning that the Linux operating system assumes you know what you're doing. So one, you get no feedback, you get no questions. Are you sure you want to do this? You can do a lot of damage if you do that in the wrong place. Yes?
The same goes for moving into, like going from the directory to another one?
Moving just uses the basic move command. So let me make directory mousey, let me make directory caddy. And if I want to move caddy into mousey, I just say move caddy into mousey. I don't need that. And there aren't any issues of moving directories around that have a bunch of junk in them. It's only removing them that's a little bit of a hassle. Yeah?
What if you're doing it backwards? Like in the outside of the file?
You want to move things out of it?
Yeah, out of it.
Okay, so there are a couple ways of doing it. Right now, so inside of mousey I've got caddy. Let me go in there. And let's say I'll go inside of caddy, and inside of caddy, let me actually zoom in here. I'm going to put whatever, my code, and I'll just put some empty code in there. All right, so I'm inside of caddy, which is inside of mousey, and in this directory, there's mycode.cpp is sitting in caddy. So let's say I want to move mycode.cpp out of caddy, out of mousey, into this directory. There are two ways for me to do it. It depends. Well, there are endless ways for me to do it. It all depends on where you are. So if I'm doing this from inside caddy, I can say I want to, in my current directory, I want to I want to move my code.cpp up to the parent, that takes it up to mousy, up to that one's parent, that takes it up to this 2019-02-06. Okay, so you can do it that way. I'm going to put when you see this symbol here, that what I'm doing is I'm just commenting out that command so I don't actually execute it. Note that this is not C++, so a comment is not 2 slashes here. 2 slashes is peculiar to C++. The shell prompt, I can actually create files of commands. In fact, that's what I was having you do, right? You had to create mycommands.bash. You could actually run that if you wanted to, and it would do everything that was typed in there. Anyway, in that kind of file, the # is a comment character. So I didn't do the move. That's still there. I'm going to CD. I'll go up 1. Now I'm inside of mousy and caddy's there. So I can say I want to move inside the caddy directory is my code.cpp. And I want to move it. I have a space here. I want to move it up to the parent. Okay, so if I'm here, that's what that code looks like. Now if I go up one more, now I'm here. I want to move from mousy, caddy, my code.cpp. I want to move into my current directory. So all those do the exact same thing. They're all dependent on where I am when I do the command. Other questions? How about Vim? Here's the general rule with Vim. If it takes you more than, say, 3 or 4 keystrokes, then there's a faster way of doing it. You want to give me something that you want to know how to do more quickly than the way you're doing it now. Yeah.
Is there a faster way to like do the compile command?
All right. Yes. So at this shell prompt, I talked about this a little bit at one point, but it's fine to reprise it. There are a number of ways of doing this. So first, your prompt here is configured to behave kind of like the Vim text editor. So how do you go up in Vim if you're in a document? K. Okay, but if I hit K, I just see letter K's here. So if I was to look at this analogously I'm in, quote, insert mode. How do I get into command mode in Vim? So if I'm just sitting here at the prompt and I hit escape, now I hit K, I can go and review all my previous commands. If I find one I like, I can just hit enter and it'll do it. Otherwise, if I want to edit one, let's say I want to edit this one and I don't know, the T's need to be D's, I can use L to move over and then I can turn those into D's and then I could hit enter and execute that command. Again, this particular command has a comment character, so it didn't do anything. So that's one way. Another way is you can generally look at all the commands you've typed by typing history. There they all are. You can rerun any of those with an exclamation point followed by the number. So for instance, if I say exclamation point 548, that's going to rerun this command right here. I hit enter, and there it is. All right. A third way is I can do an exclamation point and one or more letters, and what it'll do, I'll do HI. What this will do is it will rerun the most recent command that I executed that begins with HI. In this case, it's history. I hit enter, it reruns that. Okay. So if I want to recompile quickly, the normal cycle is, what do? You edit, compile, run, edit, compile, run, edit, compile, run, unless you're getting bugs, and then it's edit, compile, edit, compile, right? So the way that would, let me see, I don't even know where I am now. So I would say edit. Oops. Get out of that. Let me come back here. All right. I edit. I make changes. I come back. I compile. And once I've done one edit and one compile, now I can take advantage of that exclamation point, and I can go back and forth. I can say, let's say then I wanted to run. Let's say I was editing, compiling, and running. So I do dot a dot out. Now I've got three commands that I'm cycling through: edit, compile, run. So how I will do those quickly now is I'll go back into editing by typing exclamation point V. That reruns the most recent command that began with a V, in this case vim. I do some edits, I get out of it. I do the most recent command that began with a G. That'll recompile. And then I'll do the most recent command that began with a period. I'll rerun. All right? Now I can cycle through that work process very quickly just by doing that. Yes?
I just wanted to point out that you could also do it using the up arrow key.
Here?
Yeah.
Yeah. So that here at the shell, you could certainly use the arrows. Yes?
When you're in Vim and say you want to copy line 5 through 11, can you command it, I want to copy 5 through 11, or would you have to say like 6YY? Which is
good question. So the question, for the sake of the recording, is I can certainly copy lines 5 through 11 by going to line 5 and then typing. Let me get an insert mode here for a moment. YY yanks a line. If I put a number in front of it, it'll yank that many lines. So here I could say get up to line 5, type 6YY. Then I could go to a different part of my document and type P for put, and it'll put those 6 lines there. I'll hit U for undo. Yes, you can be anywhere in the document. You can say colon 6, 11 yank. It tells you 6 lines yanked. You go over to wherever you want to put it, and there you go. Yes?
Is there a faster way to do if-else statements?
Yeah, faster way to, as far as a more efficient way to kind of program them out. It depends. So I can't answer definitively. It depends on the example. Certainly, one variant to the if-else is the switch statement. Is that covered in like one of the videos or something? I don't remember.
It's coming up soon.
It's coming up soon? All right. I don't want to get into switch right this moment, but switch is a close cousin to a sequence of if-else statements. So I would look at what a switch statement is, and then that might provide some insight. And then maybe like next week or something, I'll go in a little more depth on it. So if you still are kind of wondering about it next week, then just hit me up again, and I'll go ahead and talk about it. Other questions? How about anything else in Vim? Go down here, go up here, go to line 8, go to the end of the line, go back to 3 words. All right. Okay. Let me talk a moment about the lab. So the lab has you Oh, conditional. So switch statements, is that the second lab this week?
Yeah.
Oh, okay. Well, maybe let me see. Today's Wednesday. I'm not sure what we're doing on Friday yet. Probably some sort of in-class activity. All right. So you have to write a program that's basically using these if-else statements to be able to process the way all this works. Here's what happens quite a bit. Let me actually set the lab aside for a moment, and let me approach this from a different example. So I'm going to call this Oh, what do we want to call this? GetName.cpp. I'm going to want to input my name. So I'm going to do that. And then what I can do is I can do something like this. Oh, but you know, you might want to run it also. So I'm talking to you, Brandon. I don't know if there's a Brandon in this class, but. And then you go, okay, maybe I need to do this. But Brandon isn't the only one who might run this program. My brother Mark might, so I'm going to do this. I may have to get Mark's name in here. So let me do that. Okay, at what point do I stop? And the answer is, well, hell, there are basically an uncountable number of names that I could do. So do I have to create a string for everyone's possible name? What is the error in my thinking here? If I want to get, if my task based on the name of the title of the program is to get someone's name. Yes?
You're making a string for each single name while you just write on the same line one string.
Right. So the error in my thinking is what I'm mentally doing is I'm taking all possible values and I'm making those names of variables. It's as if in calculus you didn't create a variable x, but you created a variable 32 and a variable 33 and a variable 34, and you don't stop till you've covered all the integers and all the real numbers. Right? No, it's x, and x holds any of those values, any one of those values. That's what it should be here. I want to get a name. Oops. Let me try that again. I want to get a name. And now it doesn't matter whose name it is that I get in. Yes? All right. This is the mistake that many of you are making on the lab. Straight, left, right. Now if you did this, don't worry, you're in good company. A third to a half of you have done this. But now you see the fallacy in the thinking. You don't want the values. You want what it is. What is this? Direction. Yeah, you just need one string for the direction. And then you just simply input the direction. And now your if statement looks like if direction equals right, and you probably have light color, blah, blah, blah. There's a cin statement for color there, and color equals red. Go after stop or something like that. Okay? So you'll want to do it that way in the lab. That, of course, will be in the class notes. Don't panic if you didn't get that all scribbled down. All right, so the last thing I want to talk about today are loops. Am I correct that there's been no material talking about loops yet? All right, I know a few of you who've done programming are comfortable with the concept, but we'll call this loop B. So the benefit to having a loop is it allows you to do something many times. And there are generally three portions to a loop. There is generally the initialization of a variable. There is a condition to check I'm going to use kind of formal words here, the state of the variable. I'm going to say initialization of loop variable. Now it's just a variable. It could be an integer. It could be a string. There's nothing magical about the variable. I'm calling it a loop variable simply because it's being used in a loop of loop variable. There is the body of the loop, and then there is the change and this is normally in the body. Body of loop including change of state of loop variable. All right, so let me stop being weird and abstract, get down to brass tacks. What I want to do is I want to print my name 10 times. So I will create an integer. I'll call it counter. Call it whatever you like. I can initial, so I need to initialize it. Generally, counting always starts at 0 in the language by convention, just because things like arrays start at 0. I could certainly start it at 1, but then you'll find yourself, as algorithms get more and more complex and you're bringing in more things to the language, you're finding yourself having to subtract 1 all the time. So you just gotta stop swimming upstream and go with the flow and just start your counting at 0. So that's, I want to loop 10 times. So what I want to do is I want to say while, as long as my counter is less than 10, then I'm going to put some curly braces here. I want to print out my name. I'm going to do this slightly differently. The character is the same as ENDL. So the other option is I could have said, right, that's probably what we've been seeing more, but just to mix it up, expose you to more stuff, I'm going to do it this way this time. Yes?
So that's even if it's inside the double quotes, or would it have to be outside?
Absolutely. You can do it however you want. You can do it like this. You can do it like this. It is considered a single character, so I could legally do it like that. So this is print out Todd followed by the character new line. This is print out Todd followed by the string new line that only has a single character of new line. And I know I've done a little bit of this in the past, but let me see. Let me make those double quotes. Let me make those single quotes. Mix it up. It's legal to have a string with one character. It's legal to have obviously characters can have single characters. They should only have single characters. Here's a string with 2 characters. Here's a character that's a new line. What do you see when this prints out to the screen? You see Todd followed by a new line. Here you see Todd followed by a new line. Okay, people get kind of hung up on this and they think that it's going to print out something like T space O space DD. No, because nowhere in here do you see that I'm sending a space to C out. I would have to literally add a space here. I'd have to turn that into a string, or I guess I could add a space here. So if you don't put the spaces don't print out. All right. You can also do this on multiple lines. There's nothing that says this has to be on one line. Why are you trying to convince me of that? Shame on you. All right. This is the exact same thing. Oops. There, we'll do it that way. All right, that prints out TODD followed by a new line. Doesn't have to be in one statement. Doesn't have to be all in a single set of double quotes. It's very, very flexible in how you do it. So I'm getting a little bit far afield. So let me take lines 16 through 21 and delete those. And what I'll do is I'll put them down here, but I'll comment them out so they're kind of left in the notes that you can look at later. But it's not interfering with what I'm talking about here. So I want to do my 3 things here. Initialization of loop variable, that's line 11. That's actually the creation and initialization. Those 2 don't have to happen together necessarily. Condition to check the state of the loop variable, that is inside of line 12, confirming that the counter is less than 10. And then the body of the loop is basically lines 13 through 15, including the change of state loop variable. Right now, I'm going to actually get rid of this, and I'll just print a space. It's a little bit more funny on the eyes. let's see how many times this loops. I'm going to come over here so it's up on the left-hand side. I'll say G++ standard equals C++11 loopy.cpp. I'm going to run it, and there you go. You got a design for your next wallpaper. All right. So the problem is I didn't do what I've written in a comment on line 9, which is the part after the comma, including the change of state of the loop variable. Counter never changes. So what happens is it goes, is counter less than 10? Yes, 0 is less than 10, so it goes ahead and does line 14. Then it comes back up here. Is counter less than 10? Yes, 0 is less than 10, right? And it does that forever because counter never changes. So what I need to do is add 1 to counter. I don't know if we've experienced the plus plus yet in any of the stuff you've come across. That basically, I'll give the 10 seconds on that. This is traditionally what you see in programming languages. Counter is equal to whatever was in counter plus 1. So 0 plus 1 is 1, then the new value is 1. That's so common to do in programming languages that C and C++ actually created a special operator to do that, and that's what that is. So that just adds 1 to the variable. So what will happen is 0 less than 10, yes, print it out, add 1. Is 1 less than 10? Is 2 less than 10? Eventually you hit is 10 less than 10, and that's false. As soon as this is false, it immediately falls from line 12 down to line 17. Falls out of the loop. So let me go ahead and try that again. Compile, run, and now I've only got 10 of these. Any questions on that? Yeah.
If you did the plus plus after counter, it would be subtract, right?
No, so you will, yeah, right. You're pointing out that there are 2 versions of this, you'll see. They are different, very subtly different. For our intents and purposes, they're identical. Either one's fine. If you wanted to subtract, what do you think the subtraction is? Yeah, they've got a subtract 1, and also the converse, counter minus minus, works as well. So this is what I would call a while loop. There's another kind of loop called a do-while loop. And the do-while loop looks a little different. What I'm going to do is, looking at lines 7 through 9, I'm going to initialize my loop variable. Now I can create a totally different variable if I want, but I actually want to recycle the variable I created on line 11. So I'm going to reuse that. When I get to, when I'm at line, well actually let me back up. Let me ask a question. If I do a cout statement, what's going to print out on line 20? Oops. Let's test it out. So line 20 is over there on the bottom of the right pane. I'll compile, I'll run it, and there it is, right there. That, if you now examine the code again, counter starts out as 0. We come down here, add 1. Counter is 1. Counter is 2. Counter is 3. At what point is this false and it ends? As soon as counter reaches 10. Reaches 10, we jump from line 13 to 18, hit a comment, hit this, and the 10 prints out. Okay. So let me put this here. I'll say should be 10. All right. Again, I could create a totally new variable, but I'm going to just recycle counter, and I'm going to initialize it back to 0. I'm changing it back to 0. The do while loop, again, looks similar to the while loop. I'm gonna, since I don't have a lot of screen real estate, I'm gonna change this to 5 rather than 10. And I will go ahead and print the new line after Todd. Let me use a different name, Mark. Let's compile. Let's run. Whoops. So what did I forget? Yep. So what I'll do is I'll come over to line 16. I'll say YY to yank that line. I'll just come right down here and I'll paste it right there. Let me compile. Let me run. So there are the 5 Todds and then the 5 Marks.
If you want to just have the number after mark, you just do the same thing you did to.
Yeah, so I could take this line on line 18. I could say :18 yank. I could paste it down here. And now I compile, run. You can print out counter inside here. Why don't I, rather than, let me say Todd, and then let me print out counter, let me print a space after Todd, let me print out counter, and then I'll print out that new line. And I'll do the same down there. Let me change this comment to be above the line so the spacing's easier on our eyes.
What does the /n do?
/n, so the backslash means I have a special character coming up, and that represents a new line. That's the same as ENDL. There are other ones, like the other real popular one is \T, which is a tab on your keyboard. So I'll do that. What I'm going to do is I'm going to copy, paste, and I'm going to change Todd to be Mark. Let's see what that's doing for us. So there I printed out what the current value of counter is right after, immediately after the name. What if I made counter 99? So I hit line 11, counter's created, it's made 99. Is 99 less than 5? No, so it will not do that loop at all. It immediately falls out to line 19 and it'll print 99. What if I change this to 99? It's going to hit the do, it's going to print mark 99, it's going to add 1 to counter, it's going to turn to 100. Is 100 less than 5? No. So it immediately falls out, and it would print 100 here. I can go ahead and quickly illustrate that. So note the Todd never printed out. It never entered the while loop, but it did go through the do while loop one time. That is the only difference between a while loop and a do while loop is a do while loop will always happen at least once. The while loop will not happen if that condition is false to begin with. And then there's one other loop, I'll change these back to where they were. There's one other loop that you need to be aware of. This is the loop that is, if you're a fluent programmer, it's your favorite loop, and if you're learning to program, it's your least favorite loop. I say least favorite because they're all favorites, and you really like this stuff, but this is the least of them.
Why is that?
Why is that? So the 3 things are the initialization of the variable, counter equals 0, the condition, counter is less than 10, and the change of state, plus plus counter. Okay, this is a favorite of programmers because all 3 of those are in one place and it's easy for me to find them. Now I can see that it isn't that difficult to find all 3 of those here, but loops don't generally fit into tight 4 or 5 line bits of code. I could have basically 300 lines of code right here, and this line might be at line 130, depending on the algorithm. So as a programmer, it's a lot harder for me to parse those 3 things and determine how many times the loop's going to go and what the loop's doing. Whereas here, I immediately see all that information, and it's just easier for me then to understand how many times the body of the loop's going to occur. So then all I need for the body of the loop, in this case, let me choose yet another name. I will call this, I don't know, Tanya. And compile, run. Oops, I did 10. I meant to do 5. Compile, run, and there we go. Yes?
How did you select that whole line in Vim? When you were just at, you selected the whole line. What did you press? You something V?
Oh, if I hold down Shift and I hit V, that'll
It'll
do.
the whole line.
Yeah. And then you can do, if I do hold down Shift and hit V, I can use K to go up, select a bunch of lines, and then if I hit Y, it'll actually yank all that. So that's yet another way of copying. Or D would delete it all. All right, so we will see you in lab, and then pick it up on Friday.